Okay, so this is my like adder. I'll show you the adding operation in the CPU. So what I've done here is for the register, instead of giving I'm giving manual inputs, so I've made all these into 8-bit inputs. So this will be my output. So what I'll be doing is the register 0 will have an input and register 1 will have an input. So from register 0, the input will be going on to the temporary register and onto the bus and will be stored in register B. Then from register 1, it will be going to register A. So how this happens is through the control section. This control section basically has a counter, which we call a stepper here. So every time I give a clock input here, it starts counting. So when the main clock is high, let's say now it's on 1, right? So when I make this high, it'll jump to the value, the bus 2 here. And when it's low again, it'll go to 3. And when it's high again, it'll go to 4. And then sequentially, it keeps increasing and then it repeats its cycle. And this is our clock enable. So what happens is we've given like all of our registers, accumulators, and memory address register. All of these have a set and an enable. We know that enable is to pass the information onto the bus, and set is to read or write the information onto the bus. So all the enables are linked to one another, and all the sets are linked to one another. And based on the counting operation, the data is transferred. So what happens is when we go back to the CPU, let's say I want to do this addition for 4 and 3. So we know that the normal decimal operation will give us a 7. So in terms of binary, it's an 8-bit representation. So what we do is when I trigger this pulse here 4 times, the bus input, the register 0 having an input here of 100 will be sent on to the temporary register. We'll now see that. As you can see now, the data is now here being transferred to the temporary register. And when we go back to the control section, we can see that clock enable is turned on, which means that we are passing on information onto the bus. And from the bus, it has to go to the temporary register. As you can see, the set's not on yet, which means the data from the register 1 has only reached the bus, and for the data to be written onto the temporary register, the clocks of the set clock should be turned on. So when I go back to this and when I repeat the process again, it should have come here at this point. So now if you can see, you see that we've moved on to the accumulator section, which means that the set clock is on, which means the accumulator has stored data right now. And similarly, the process repeats for the other register, but the second register directly goes on to the A register here. It doesn't go through the temporary register because that's how we structured it to be. And once this process is done here, the information to be passed on to the accumulator only when the set is on. So only when the enable is on, the information is passed from the accumulator to the control section. And then from this accumulator, for it to go to be written onto the register 3, the set should be turned on. So you can see when the set is turned on, the information was passed from the register, from the control section, to the final register, which is our R3, which is our final answer, which is 7. You can see that we will receive our answer here, 0111, which is 7. That's it for the addition of two numbers.